Good morning, everybody. If you can all take your seats, we're going to go ahead and get started here. So my name is Eric Putnam. I am the account executive for DTIC, the Defense Technical Information Center. The man standing here to my right is Andrew Pedrick. He's been the program manager for the DTIC Master Data Repository for about 4 years. And Andrew's brought quite a talk this morning, and I'm going to let him take over and kind of dig into some of the very cool things that DTIC has been doing, some with the MarkLogic technology and some with other technology, and I'll let Andrew kind of talk to that. Here's Andrew.
Try again?
There you go.
Bug is fixed. Okay. Should we turn this off? I don't know how to do that. All right, great. Thank you. Okay. Where's our clicker? You just heard this a few minutes ago. I'm a government employee. I'm going to talk about our wonderful success with Oracle. MarkLogic. Please don't take that as an endorsement of a product. So I'll talk a little bit about our organization and the challenges that we were facing that brought us to implement MarkLogic, and then a little story about our implementation. So as you heard this morning, DTIC is a small DoD agency, about 200 or so employees, and our mission is to deliver scientific and technical information to the Department of Defense. Essentially, we are the Department of Defense equivalent of the National Library of Medicine or National Agricultural Library. We collect the results of DoD-funded research as journal articles, technical reports, conference papers. We also collect information on research projects that are in progress. We collect budget information, acquisition data, and we pull all this together, we catalog it, we nurture it, curate it, harmonize it, standardize it, and make it available through search products and analytic tools. We serve not only DoD, but also other federal agencies and the public. And I'm just going to jump to the next slide. So typical use cases for people coming to DTIC, so a person out in the field, a warfighter at a combatant command, they may say, our adversaries have developed laser blasters. Are there any countermeasures that have come out of the labs that we could use to address this? An engineer may have said, I've built a lightsaber, and are there any power sources or batteries that the labs had developed that might power this thing? Another engineer may say, I'm about to build a lightsaber. Has anyone already done this? Can I build upon it? Can I improve on what they've done? Lab scientists doing basic research may have figured out how to use the Force, and of course they want to publish their discovery and share it with their colleagues. Another scientist may say, well, my field of research is telekinesis. Is anyone doing anything cool in this? They're just trying to keep up abreast in their field. And then of course leadership wants to know, what are we funding? How much have we spent on this different research? Do we have anything to show for it? And maybe should we reallocate funds? And these are all real-world examples. We have developed this. It's on a classified network, and I assume you're all on a need-to-know basis, so it doesn't leave this room. So we have a number of different front ends that we use to serve our customers. This is many of them, not all of them. It's kind of a lot for an organization of our size. And these products exist on the public internet, also on a secure network, the NIPRNet, which Gary mentioned in his keynote yesterday, and also on a classified network. We generally have a flagship search product that searches most of our content that exists in some form or other on all three networks. The reason we have additional products is it will shave off a piece of that data for a particular community to meet their use cases. Then, of course, we have other products that are indexing and providing other data sets that aren't available through that primary search product. We have many different data sets. They vary greatly in size. Our primary collection is the technical reports collection. It's essentially bibliographic information that's describing those documents, so title, an author, and abstract. And its size is about 2.5 million records describing documents. We also curate those documents themselves, about 1 million we've digitized and available in PDF up on our various products for people to access. The rest still exist as microfiche, microfilm. Of course, we have projects underway to scan those and digitize them. We also have a digitization on demand service where people can put in a request for us to speed up digitizing an old document we haven't gotten to yet. So the biggest collection is 2.5 million records. Next collection is about 1.5 million, and then 300,000, 170,000. All the rest of them are in the spans of thousands of records or tens of thousands of records. So when our primary search product pulls in just the primary collections, the top 4 or 5, it's really 99% of our content. So as you can imagine, the story is getting old now with all these different products, all these different data sets. We have many different silos. Silos of data, also silos of projects, silos of development, silos of people. We've made some progress in breaking down the silos of people, not so much in breaking down the silos of data. We have gone through a number of different search engines, many search engines, pulling in our data and indexing it, but the data itself is still sitting out in the legacy repositories on file systems and Oracle and MySQL and so forth. And this leads to a number of different challenges. In 2013, we're about to jump ship and go to another search engine, and we considered maybe we should try to address some of the other data management and infrastructure challenges that partly stem from having our data in our projects in silos. So we grouped those challenges in 4 different categories: storage, security, search, and analytics, and there is some overlap across them. But in storage, our main issue was we had not pulled all of our data together into a single repository for reuse. So that meant as each time we went to another search engine, we couldn't pull the data out of the old search engine, migrate it to the new one. Instead, we'd have to re-ingest everything again from the legacy repositories, which would invariably lead us to rebuilding all those ingesters. We had the same issue with analytical tools. Again, every time we'd change analytical tools, we'd have to re-ingest everything. Also, because our data was not centralized, it made it more difficult to reuse the data in separate products. So in our main search engine, we had pulled in our primary data sets, but not all the little cats and dogs. Those are still being served in different silos. And as a product owner for one silo would recognize the value of integrating with another data set, we would migrate that data from one relational database to another. And in my organization, that typically took 6 months to a year. Even if we're just moving data from a relational database into one of the many search engines we were running, that also would take just about as long. So we weren't able to effectively and efficiently respond to the dreams of our product owners. It was also difficult for us to add elements to some of our core collections. We had an old document management system that was very reliable, but like some of the systems that have been described in some other sessions yesterday, no one wanted to touch it for fear of breaking the data flow. And so whenever there was a need to add an additional element, it was injected, shoehorned into an existing table and column, which just added to our data management and data quality issues. Our data flows were at high risk because there are so many steps involved in them. So as an example from one of our input systems for our primary collection, where a user would upload their report or their journal article, from that point to the point on the public search, where they could come in and search for that same thing that they just submitted, there were 13 to 14 applications that data passed through. For some, there was not a particular team responsible for the application. There may not have been documentation as to how to manage it. And so whenever there was an issue that a document didn't pass all the way through, there was a big cost in trying to figure out where it broke, how to fix it, and to fix that. And this also led to many different copies of the data because each of those processes would tend to make an additional copy, which would add to our security risk and add to our maintenance risks. And in those cases where there's just a single data set used by a single silo, and we migrated it to another silo so it could be reused, that of course would add to our data copies to manage. Security system we had at the time was custom built in-house, attribute-based, element-level security. And this came into play when a user would come to our search system, they run a query, they'd see the results, they click on an item to view the record, and this system could look at the user's access rights in our registration system, and also look at the document markings, all the attributes, controlling that document, and determine whether or not they could view the record, whether or not they could view individual elements within the record, whether or not they can view the document or order the document. And we needed this element level security in our search systems because we allow for discovery. So there's certain documents that a contractor cannot view. We want them to be able to discover those documents so they can then request access to them from the controlling agency. So that's why we have element level security there. And the system dealt with all of our crazy markings because they're inconsistent across the different data sets. And even when they exist in multiple data sets, they may be represented in different ways. And even when they're represented in the same way, there may be deliberately different policies on those markings for different data sets. But it addressed all that, and it worked wonderfully. The issue was it was only being used on our flagship search product and only for our primary collections. And so when data was copied out into another silo, they were using different security on it. And for all the other data sets, through all the other products, again, they're using different security systems, usually in a cruder form. It was not element level. It's either you see it or you don't. And so our users would have different experiences with our data based on which product that they accessed. And the reason for this is because, sort of like the document management system, no one wanted to touch this, no one wanted to update it, because it really dealt with our security. It was very robust, but no one wanted to take that chance. This also had the issue that it made an additional copy of our data. The search engine that we were running at the time, this is in 2013, was very good for what it was built for, but that was not our industry. So it was built for searching the internet. It looked at relevancy based on pages linking to each other. That's not what we had. We had static documents. And we are in the publishing, abstracting, indexing, library industry. And so our competitors' products and our former products have the ability to run a query and get a precise count of results that is dependable. And our users depend on that to analyze the collection. So they can see, oh, the Air Force is doing a lot of research on lightsabers. The Army is not, or the Navy is. The search result counts we were getting from the search engine were highly unreliable. They were just really rough estimates. I mean, you could not use them to analyze the collection. Also, in our competitors' products and in our former products, their users could run queries that would honor Boolean logic. So they could use and, or, and not in parentheses. They could use truncation. They could use little indicators to specify the fields. They could do really complex field searching, and the search engine did not offer any of that. So our users had some issues trying to achieve their mission. So of course, it didn't support any sort of analytical queries. And being a search engine, we couldn't pull the data out to do further analysis on it, even though this was the one place that we had sent all of our data. We had a fair understanding of our different data sets and how they could conceptually be linked together to answer interesting questions. So we had budget data, we had the research projects that were funded by those budgets, we had the technical reports that came out of those research projects, we had information on the usage of each of those things and what users were looking at in terms of the reports, the projects, and the budget. We knew what organizations they worked for. So some really interesting questions that we could answer. And of course, there's multiple edges that would come off of these nodes. Our issue was we did not have any platform in which we could store RDF triples or run Sparkle queries. And we had implemented some BI tools, but our experience was we would only load in one or two different data sets, almost never our actual usage data, so we could answer more interesting questions. And of course, we didn't have a data warehouse to support those business intelligence tools. When we would implement them, again, additional data flows, additional copies of the data, additional security. So the solution that we envisioned was, imagine if we could pull all of our data together. Let's include both structured and unstructured data. And when it's structured, let's be able to cover different schemas. So we'd still have to do some data modeling, but this might cut down that time frame a little bit. Let's have the system have the built-in element level access control so that everyone accessing it would experience security in the same way, and we'd have just one place to update our security policies rather than a dozen. Let's have full featured search, so all of a sudden our users could, again, do what they have done before on our systems, and we'd be up to par with our competitors. While we're at it, let's also ask for supporting analytical queries. We can connect BI tools with this. And sure, let's also do the semantic data. So we're loading semantic data into the same system, so we're not going to be in a situation of some organizations where they have a search system, they run a query, they pull the data out, and then they run it against the semantic system, and they try to merge and manage the data. So, and if I wasn't clear, all this in one system. We didn't want 4 different pieces, 5 different pieces, 6 different pieces. That's what we already had. All right? We wanted one system, one set of data flows, one security. The name that we came up with for this was the master data repository, not because it was going to be a repository of master data, but instead it was going to be the master repository of our data. And the goals pretty much match that vision. So full operational database management system, create, update, delete, multi-schema, unstructured data, full enterprise search, element level access control, and the semantics. But we understood the issue of the error of just throwing technology at a problem, so we recognized we really need to consider the data. Data is really our bread and butter at DTIC. We also need to consider the people, make sure that their requirements are being met, make sure they understand the benefits of moving to this system, that we communicate the progress to them, and then to get training on how to use it, and that we establish processes so that data owners can move their data to this system and product owners can move their products to this system without a whole lot of hand-holding, and so that we don't end up with the proverbial data swamp. So some distinctions of our use case, we're looking at content data, not so much transaction data or internal business stuff. This is our content. This is our product we're providing to our customers. And as I mentioned, we did not have a data warehouse, but we had gone through a series of search engines. So we had a lot of experience mapping our data sets to each other. We also had an existing live front-end product. So DTIC had been doing agile development for a while, and we would do agile development in this effort. But we wanted to make sure that when we finally cut over, our users had all the capabilities that they had in the previous system, plus some new stuff. We didn't want to release a new iPhone that only called West Virginia. We wanted to do everything as before, plus new stuff. And also, we wanted the attribute-based element level access control. So this was in 2013, long before MarkLogic, I think, had advanced security. But my former colleague at DTIC, Dan Witcher, started to look at different technologies that might be available. And one that he happened upon was NoSQL databases. And one of the vendors he brought in was MarkLogic. And so MarkLogic came in, made a bunch of glorious promises that couldn't possibly be true. And the next year we brought them back in for a pilot project. So we gave them 4 different data sets. Some of them were clean, some were a horrid mess. And they ingested those 4 data sets, implemented the full search capabilities that we had been missing before, implemented the element level security, and also demonstrated the semantic capabilities in 6 weeks. And this was with 2 developers. Now, admittedly, they did not have to go through security reviews. We didn't deploy up to production. This was all on development, but they proved that a NoSQL database might be a solution for us. So we continued our market research, went through the entire contracting, and then in 2015 came back to MarkLogic and ended up purchasing licenses and professional services. So I'm going to delve down into a bit detail of the 2015-2016 timeframe, and then come back and address the rest with a broader brush. So first project was building out the master data repository. And in this, we were replacing the entire backend for our search product. So that search product, a person would come in, they'd run a query, and it would call our search engine. And they would click on a record, an item in the hit list to view a record, and it would call our access control system. They would click on a link to view the document, and it would go back to the file system to get the documents. And that access control system also reached back to all the legacy repositories. I'm going to put this down. So hit all those too. And as a person was running queries, we were also storing records of everything that they did. So Bob ran this search, Sally looked at this document, Fred requested this record and got back an abridged record. That's going into another database. We also allow our users to store items that they find, to store a hit list, and also to generate bibliographies, to export those, to save searches. All that's being stored in another database. We replace all that with MDR and MarkLogic. So to accomplish this, we ingested 15 different data sets, really 15 different schemas, totaling 4 million records, 1.5 million PDFs. We established a bunch of new collections to track our users' usage. We established the access control, the element level access control across all of our content collections, created 150 some indexes. We established a simple search language so our users couldn't, again, use Boolean logic, could specify particular fields and do really complex queries. And the front end, we did not redesign the user interface at all. We simply updated that to call this one system. And this was all within a year with 1.5 MarkLogic consultants. Eric was part of that half part for a few months. He helped us out greatly. And 5 developers. So that was pretty remarkable for DTIC. And so in that project, we laid the foundation, using MarkLogic. We also built the house and we moved everyone into it. So all of our users were using this system for our primary product. We also had a secondary user interface that would search a sliver of that information that also was modified to query the MDR in MarkLogic. This just points to we use a number of different methods to ingest the data. So we had some custom Java ingesters that we built for our primary collections, primarily because we had the requirement to be able to re-ingest a data set within a couple days. It should not take weeks, should not take months as it had with some of our previous systems. And we used MarkLogic Content Pump to deal with collections that were going to be loaded just once, or with collections that, as the one that Eric worked on, we found out was not quite as clean and pristine as we thought, and we had to do a number of ingests of different schemas just for one data set. We did implement the envelope paradigm, and when MarkLogic first talked about this, it was a bit of a mystery to me, but now it seems pretty simple now that I understand it. So these 3 boxes are excerpts from just one XML record from our primary collection, the technical reports collection. So again, that's bibliographic data, title, author, abstract. The first box is our raw data that we pulled in. This data was being managed through a document management system, the one I mentioned that we didn't want to touch, very normalized database on a separate network, and that would feed I'll say a LilyPad database that had been set up 20 years ago, maybe 25 years ago now, to facilitate search engines pulling out the data. And that database is fairly flattened. I'm going to pretend it's one table. It isn't, but it's sort of like having one table with every record represented by one row. And because of that, it made it very easy for us to pull in the data in a raw format. We're able to say for every column, make that the element name and stick the data in just as you found it in the source database. So we pulled in all the raw data. And this is represented as an envelope within the XML record simply by the fact there's a particular parent name, and all of those elements coming from that database are children of it, and then also they're grouped by a particular namespace. The standardized data, or the curated or harmonized data, is just simply another parent within that same XML record with additional namespace, and of course different XML elements that were more standardized across all of our data sets. Because as I said, we'd already mapped our data sets to each other multiple times as we went through many different search engines, so we had an idea of this is going to be our kind of standard format. Not strict entities, perfect across everything, but it worked well for us. And this is much more hierarchical, so there's more parent, child, grandchild, and so forth. And for these values, as we pulled them into the standardized set, in some cases we would correct the data. So we had dates that were stored as strings. We'll convert those to actual dates. And the standardized data we standardized almost all of the raw data. We also had a third envelope within the same record, and this described the PDFs that these documents were associated with. So again, separate namespace, separate parent, bunch of children. And there was elements describing, yes, there is a PDF, this is how big it is, yes or no, we were not able to pull full text from it, and if we were able to pull full text from it, here it all is in one element, and that's how we enable full text searching. For this particular data set, we ended up standardizing most of the data because the front end demanded it. Right? We're working against an existing front end, so we wanted to make sure we standardized everything that front end demanded. And then also we needed to index many of these elements because of what the front end required. But we didn't always do that. In other cases, we had fairly flat systems we're pulling the data from, but we only need to display a few of the elements in that front end. We only need to index a few of the elements. And so in those cases, we only standardize those few. In other cases, we're pulling data from a source that was not flattened in any way, did not have a materialized view. This particular one was quite painful, so it was a very normalized database, hundreds of tables. It did have primary and foreign keys in it, but there was no links between the tables within the database. I guess they used Hibernate or something. That was highly entertaining to trace through and pull the data out, and once we pulled all that out, we just went straight to the standardized form. Just going to show our methods were driven by the nature of the data and what the front end required and what our requirements were. In my mind, data documentation is very important to keep track of your data and to make sure you don't end up with the data swamp. If you just pump the data in, you will lose track of it. So in implementing a number of different search engines, we had developed these maps. that would map the similar elements across data sets, and also kept track of the source of the data, what tables and columns it was coming from, what the data types were. Adding to that, for moving to MarkLogic, here we're ingesting the data not just for search, but also for storage. So we're pulling in all the data. We mapped up the XML schemas for the raw formats. We mapped out the XML schemas for the harmonized formats, added information on the ETL that would need to be done if we're correcting any of that data. And then, of course, the index types. And then also, finally, an element, the label that's used in the front end. So if the tester finds out that there's an issue with supplementary note or title or whatever, they can trace back and find out where that data came from. This is also useful if you've used MarkLogic and you're in the admin module and you're developing indexes. Let's say you have a field index and you're putting in maybe some absolute paths or some relative paths. Let's say you just have a relative path to title, and that's really useful and it's very easy, but that may not tell you what data sets that index is actually querying. And so by keeping our documentation, we're able to say, you're searching title, that exists in this data set, but not this one. Anyways, it's an example of a search screen, just trying to illustrate what I mean by the Boolean queries. So again, using parentheses for nesting and or not. It's kind of simple stuff, and our previous search engine would look at this and it would accept the query, but it wouldn't exactly honor the logic. So it's kind of misleading our users. And of course, we have boxes for doing field searching, but our users also, and this would generally just and the fields together. Our users generally want to do things that are more complex, and so we allow them, it's not illustrated here, but in a big box, specify individual fields and combine them with and or not and really mix things up. This is one of our security scenarios, and so using MarkLogic, the system is able to look at the document's markings, look at the user's attributes, and then decide what the user can actually do with different pieces of the data. So that was 2015, 2016, where we built the house. The following year, we moved everything up to the classified network, both of those interfaces and systems, and we also migrated an additional system that previously had been its own silo. International Agreements was also migrated to the MDR, and it's using it for both input and for search. Following year, we were nearing the end of our professional services, so we asked MarkLogic to do an assessment of what they had implemented with us and give some recommendations. At this time, we also considered pulling in data from a new document management system. So that old one that we had issues with, right before we started the MDR development, they started replacing that document management system. So at this point, that is now up and live, and we're looking to ingest data directly from it rather than that LilyPad database that's between us. This year, DTIC has gone back and has redesigned the user interface for our flagship search product, and has also built out a custom analytics tool, sometimes called budget tools, and now has a different name. And so we're supporting, through MDR, those indexes that they need and new transformations for more standardized elements. We also had professional services back in to help us out with a few issues with our implementation. And one of the neat things that they did was offer a summing facet for the budget tools team. So typically with a search facet, let's say you arrive at DTIC site and you do a search on lightsabers, and there may be a box on the left or the right hand side, and it'll say out of these 50,000 results that you found, 30,000 were from the Air Force, 20,000 were from the Army, 5,000 were from the Navy. I guess that was more than 50,000. Anyways, they wanted, instead of just counts of records, they said within these records there's actually funding information. We want you to sum up the funding from each of these agencies within the facet. And so professional services was able to build that out for us. Budget tools team was thrilled. And professional services also informed us how to move forward with that so we can meet additional requests for that. And of course, they've asked for other funding facets. We're also moving forward with removing additional dependencies on our legacy storage so we can shut down some of that storage and further simplify our architecture. We look to do a pilot with advanced security to see how much of our security requirements can be met by that. We're migrating to MarkLogic 9. And our IT department is moving our entire secure network up to the cloud. 2020, classified's going to the cloud. looking to use Apache NiFi more, possibly implementing advanced security, depending on how the pilot pans out, and then returning back to semantics. So we had gotten the semantics option with MarkLogic. We'd done some pilots on development, but we've always had other priorities. We've never really rolled it into our production systems, and so hopefully we'll return to that in 2020 and really take advantage of it. So looking at our program goals, we pretty much hit the mark on all of those. Operational database management system, we're loading data that's structured in many different ways. We're loading in unstructured data. We have the full search capabilities. We're doing the element level access control, and we demonstrated the semantics. On this slide, yep, we definitely hit the technology mark. Data mark, we're doing pretty well. People, yep, we socialized the benefits. We provided training. I think we're still doing some transitioning there. On the process side, that's where we need to do some more work. So we have some procedures in place, some guidelines in place, some are still in draft mode. But we need to make much more progress on that so that people can move their products to the MDR, further reduce our infrastructure, but do it without so much hand-holding. Next few slides show an embarrassingly simplified view of our public and secure networks. It does not show all of our products, does not show all the ETLs or all the storage systems, but I offer it to give you an idea of what we're trying to accomplish in simplifying our infrastructure and implementing MarkLogic. So on the left-hand side are our input systems. That's some of them, not all of them. We have many of them. And the second one was our primary input system that was feeding that document management system. These, of course, are feeding data stores, which then have ETLs that are pulling them out and putting them into other data stores, or into search engines, or into access control systems. Then finally, on the right-hand side, our users are coming back in to view this content and make use of it through search and analytic tools. So that was how it looked in 2015 before we went to MarkLogic and the MDR. Today, we've consolidated a lot of that. So we have a central store where all of our primary data is going in. We have the search built in, the access control built in, analytics is there, multiple tools are querying it, and we've eliminated some ETL in some of our legacy data stores. And we're starting moving some of our network to the cloud. End of this year, everything's supposed to be up on the cloud. And as I said, we're also looking to remove additional dependencies on those legacy data stores so we can shut those down, reduce our maintenance, and reduce the number of ETLs that we're managing. And of course, in the future, simplifying even more. I must have talked really fast. Because when I'm talking to the squirrels at night going through this, they say, Andrew, you're taking much too long. And I go like 50 minutes. But they know all about MarkLogic now, so it's good. So continuing challenges is really just one of these I'll focus on. And that is that we are still learning NoSQL, we're still learning xQuery, we're still learning MarkLogic. So it's a big mind shift, I think, to go from relational database to a NoSQL database. Those who are on the team, I think, have made that shift. They may not have all the solutions for NoSQL that they have for relational databases, but at least they're thinking that way. I'm still in the transition, but certainly those outside of the project, I don't think have quite made that transition yet. And certainly it isn't necessary for everyone to understand how the data is structured, but having some of that awareness, I think, helps them plan and understand risks and capabilities and opportunities. We're still learning xQuery. I know MarkLogic seems to be supporting JavaScript more and more. I don't know how far they are in that transition, but certainly some of our team have learned xQuery, some are using JavaScript. And then there's just understanding how MarkLogic itself works and how to administer it and how to address any performance issues that come up. I think we've made a lot of progress in that. We're never going to be the same level of experts as MarkLogic consultants are, but we're still moving forward on that. Contributors to success. So I think it was important we had very clear and consistent goals that we've stuck through over the years, and we had very tangible functional benefits, and there's also a cost benefit. So our previous search engine, comparing the licenses for that to the perpetual licenses that we got with MarkLogic, one of the reasons that we went with MarkLogic was it had perpetual licenses. And then adding in the professional services on top of that, we still had cost savings within about 3 years. And that's comparing just search to better search that had the features that our users needed, plus storage, plus security, plus analytics, plus semantics, plus professional services to help us do it all. So definite cost benefit there. And it was a prime motivator that we did not want to have to renew our previous license for the search engine. So that very much ensured that we would complete our effort within a year. Certainly using a NoSQL database was critical to success. I don't think we could have done this with a relational database or just a search engine. Or doing the pilot project was really important so we'd understand the capabilities of this technology rather than just jumping into it blind. And professional services were absolutely essential because we did not know anything about NoSQL databases or how to administer MarkLogic, and we would not have succeeded without them. And my favorite, I think it's really important to understand your data. And if you don't understand your data, to have SMEs who do. Because again, if you just dump it in, you're not mindful about structuring it, you're not keeping track of it, regardless of what product you use, you're going to end up with a mess. I think I'll stop there. Are there any questions? No? Good. Oh, there is a question. Okay, all right. Okay, thank you.
So you said one of your goals is semantic?
Yes.
What do you think that's going to add to, can you describe that? I'm not clear. And then what do you think
Yeah.
that's going to add to your search success and your implementation?
So right now we still have, although we've pulled all the data together into one system and we can search across all of it, we're not really leveraging the possible links between the data. So in the past, we could say, what document has been viewed the most? This particular document has been viewed the most. These are our top 10 viewed documents. That's great. Doesn't tell me anything because I don't know what those documents are about because that's in a separate system. Right? Our logs were in one system and information about the content was in another system. We've now put those into one system, which is great, but we have not really taken advantage of that to say, people are looking at stuff about lightsabers, right? Top 10 documents are all about lightsabers. We've not made that connection yet. So this is how we would use that, at least on the back end. And then I think there's even smarter questions out on the front end so that decision makers can see how they're spending their money, what's being used. So for instance, maybe they're putting $2 billion in a particular program. A bunch of research is coming out of that, and no one's looking at it. Right? Or maybe the Navy's funding all this, but the Air Force is the one that's leveraging it. Some of those things are useful to know. Yes, sir.
A couple of questions. When you moved to the cloud, did you make any significant changes? Sorry, did you make any significant changes to the deployment architecture? And when you went to the cloud, I assume this is a mission critical system. It's got to be up all the time. It's used 24/7. How did you implement, the kind of monitoring and service availability for your customers?
I'm going to be thrilled when I have the answers for those questions. That would be great. So, as Hip mentioned this morning, we've moved our development environment to the cloud.
Okay.
Right. So that's one thing. They're looking to move both of our staging and production environments to the cloud. It's not really started yet, at least not to the point where I'm aware of it. I know that they're moving forward, but they're not pulling my strings yet, but it's supposed to happen this year. So, yeah. And I think one of our saving graces is we're not exactly 24/7. Right? We can be down for a few hours, not for a whole day. We can be down for a few hours and make that transition. And from, I think, Eric's presentation yesterday, from my experience with MarkLogic and the advice that they've given and what they've done in moving to the cloud, it's probably going to be something similar, where you do a backup of the database and you restore it. And we're going to do what the vendor recommends.
Okay.
Yeah. Is that the right answer? Okay, good. All right. Yes, sir.
Yeah, you mentioned. You mentioned Apache and NiFi. Where are you using that?
Where are we using it? Right, so right now we have the master data repository. That's our production system. The system that Hip talked about this morning, the Global Research Watch, is sort of in a research phase. And so they're testing out NiFi, seeing how to use it, what the best practices are. And once they complete that evaluation, then I'm hoping we're going to use it for, so there's a couple collections that are in this new document management system. We're working on the first one. I hope we'll use it for the second one. And then certainly as we merge the two efforts, Global Research Watch and MDR, we'll be leveraging it much more. But right now, it's still sort of in the test and evaluation phase. Any other questions? Yes, sir.
Talk about your MarkLogic content palm. Can you talk a little bit more? In the beginning, you talk about MarkLogic content palm, MLCP. Can you
Yes.
talk a little bit more about how you use it, how you feel that tool?
I might let Eric take that one.
So as, I don't know, this is on, so I'll speak loudly, or actually I'll grab your mic.
It's on now. It's on now. Yep.
So as Andrew indicated, they're looking to switch to Apache NiFi as the ingest capability, but back when they started building this project 4 years ago, NiFi was in its early phases, so we used MarkLogic Content Pump to do a lot of the ingest work that DTIC has across their collections.
Yep. Anyone else? Yes, sir. Oh, wait for the mic, please. Yep.
The last page you said, you said you focus on the backend. What exactly mean? You mean in the front page, I think you talk about the standardized data. So you said the front end required. So basically for this new project, I know you build a new MDR, so you don't still reuse the old UI tier?
We did use the old UI. This is as we move from search engine to search engine, my impression is within the organization that was exciting for us. And so we also see it as an opportunity to redesign the user interface. So to kind of reveal to the users, oh, we have these new capabilities. And so in all the other projects I've been on, as we move to a new search engine, we completely redo the user interface, which would add to the time to develop the project and to make the transition. Here, in this project, I begged management, let's not touch the UI. Let's not stop and redesign that, because that's going to slow us down. We want to make sure this is done before our search license expires. And also in doing that design, that redesign, that leads to changing requirements, which screws up everybody. So that's what I mean by that. We left the user interface as it was without redesigning it and simply changed what it was calling. Okay. Yes, sir.
Earlier you mentioned that you're using the access control on the element HPU level.
Yes.
Have you done any measurement on how much overhead to the performance on the search?
My understanding is that's pretty fast. So I should also clarify, so we have several different levels. Person first logs in, they're going to SiteMinder. And then when they come to the search screen, there's a certain level of, can they simply search a collection? And then beyond that, once they can see a collection, we show them all the results from it. And it's only when they click on a particular hit that it goes to the access control again to say, how much of that record can they view? So when a person is doing search and it's, let's say they set it to 25 results, we're not doing access control on each one of those. We already checked it at the collection level. Any other questions? Okay. Thank you very much.